Okay, clear is it? Guys, is it my voice clear?
Madam ada
Clear,
share
clear.
Clear, madam.
Suara clear.
suara
Okay.
clear tapi kalau apa madam share screen tu tak ada.
Not yet. I'm going to share the screen now. Okay, so for today class is we are in week is it? Okay. Okay, we are in we are in weeks where are we? Okay, we are in week week berapa?
Week 10.
Week 10. So we're in here, week 10. Alright, since we are week 10, then we look back at our lesson plan. Our lesson plan, it should be in chapter 4, flow in pipe. But since this today is for the tutorial class, it means that we don't have to cover for the lecture dulu lah. We go for the question for the chapter 4 on last week class. So it's going to be, we have some of discussion. Okay, for the linear momentum and application, and which I already told you for the last week we will discuss one of the question from the chapter 3. Is it right?
Yes, madam.
Yeah, so kita recall back. So we are in chapter 3, linear momentum. So in linear momentum, you should know about the, what is it? You should know about the conservation of linear momentum. What's the formula or equation you should use? And another one, we will calculate the anchoring force of linear momentum. This one, this is cover for the pipe lah. Alright. And after you finish for chapter 3, we will have the assignment too, and also the final examination, final exam. It will cover for the final exam too. Alright, okay, now for the linear momentum, it's in here, this one. Okay, since we are in chapter 10, oh not yet. Okay, kita tak masuk lagi. It should be tomorrow, but never mind. We cover for the linear momentum first for the equation as we recall back on an exercise. So the linear momentum here, we already covered for the linear momentum. The overall of what is linear momentum, it should be it should be what? Siapa tahu? Who can remember linear momentum? Masih lagi masuk. Did you still remember what is linear momentum? It's come from the second Newton law. And the Newton law state that rate of change of momentum body is equal to resultant force acting on the body and take place in direction of the force. It means this is the general equations. So total of F is a total force. This one is total force in either X direction, Y or Z direction. This is depends on the question which you should cover. Sometimes there is only one question for the past year. It cover for the X, Y and Z. But usually it just cover for the X and Y direction saja. But the one question for the final exam is cover these three direction, X, Y and also Z direction. But never mind, for the total force, it should cover for the, what is total force here? It means that it's a net force subject to the control volume, which means it is covered for the pressure, reaction and also the body. The body is total weight. This one either Fx, Fy and also Fz. Depends on the direction. And the pressure itself adalah, it comes from the pressure. It means that F equal to, guys, F equal to, related to the pressure.
MA.
MA with the pressure.
P over A.
P over A.
Go.
This one. Is it F equal to P over A?
PA.
PA, alright. So P equal to FA. Sorry. So it means here adalah P adalah F over A. Then F equal to P and A. So this is cover for this one lah. Boleh Nasuha? Siapa tadi?
Boleh madam.
Alright,
Bagi.
so F equal to P and A. So we have these three forces on the total force, and this one adalah total force equal to M dot, this one M dot ni, and times with the delta V is direction of the changes for changes velocity. This one, it means here adalah V2 minus with V1, the changes momentum in control volume. It cover for the V2 minus with the V1. This is the M dot. So M dot equal to rho Q. So this one adalah V2 minus V1, the changes in the control volume velocity, this one. So we will elaborate this equation, total F equal to M dot, and this is the changes of the volume. For the X direction, this is for the X direction. Total F X direction by the X direction equal to M dot V2 minus with the V1. So since M dot equal to rho Q, it becomes total force X direction rho Q velocity at out. Ni outlet This two is mean outlet. And this is inlet. So it's noted as V1. So this is for the X direction. Same with the Y direction. Total at the Y direction. M dot of rho Q. Outlet minus with the inlet. Same with these Z directions. Okay, sometimes the question you need to find for the total force, it means you need to find for the resultant force here, this one. So since you have already the Fx, Fy, or you have the Fz, you include also the Fz here. But if it's just only for the two direction, you just include for the Fx and also the Fy. So it become Fr, resultant force needed for the question, Fx squared plus with the Fy squared. Or else if the question covered for the Fz, you need to plus the with Fz squared. So the end you can get the Fr direction here. Same with the direction. This is the actually the question need you to find the direction. So if it's mean for the direction, you need to this one direction. It means that you need to find for the theta here. Theta equal to Fy over with the Fx. Okay. Ini if is only 2, if also with the Fz, you need to Fy, Fz, and also and so on. Alright, this is some sort of the linear momentum, the basic. Okay, is it clear for this one before we go for the example? So easy, right? Sometimes we need to cover for the beta. Beta usually we assume as 1.03. It's so small, I mean 0.03, we assume it as a 1. Okay, that's why usually there is the beta here. Okay, some of the question they already given for the beta, and the beta mentioned that is 1.03. Some adalah is not given, so we assume that as a 1. So that's why kita tak letak beta in here. Kita assume as a 1. Alright, is it clear?
Clear, madam.
Okay, this is how we want to solve the questions. So never mind, saya takkan terangkan ini. We just go straight to the question. We look one for the question. Okay, we go for question. This one took some time. 1 hour is not enough. We go for the quite simple question. Which one? Okay, this question. So we go for this question. Right. We go for the one example here. October 2016. Can we use this question?
Yes.
Pasrah tak ni? Okay ke ni? Is it okay? Any question
Okay,
before we
okay.
Okay,
proceed?
madam.
Is it clear?
Clear.
Clear,
All
madam.
right.
Clear.
Okay, that's good. So now we look at this question first. Before we proceed, we need to, saya ingat. Okay, never mind. We need to read the question first. So figure is showing a reducing elbow reflecting water flow at a rate of 30 kilogram per second. Mass flow rate in a horizontal pipe downward by an angle of 40 is in here. The cross-sectional is already given. The cross-sectional is doesn't it's mean that you don't need to find for the area from the diameter. Just use the area here. And this is A1 and also the cross-sectional for the A2 given. The velocity measured at the inlet, this is for the inlet. And this is outlet, right? V1 and also V2 here. Okay, so what's the value for the inlet? Is a 2 meter per second and also V2 is 12 meter per second. The elevation difference between the center of the exit and also the inlet, this one is 0.6. The mass, okay, is given. The mass of the elbow and the water in the pipe system here, this one, is a 50 kilogram. It means you have a weight. Determine the magnitude of the carry force needed to hold the elbow in place if elbow discharge water into the atmosphere. So you need to find for the inquiry force upon, call it as the Fr. So since there are two only here, X and Z, so dia tak bagi Y, dia tak guna Y, it use Z. Never mind, kita just guna Z. Noted as a Z, never mind. So this is the positive, it means. So Fr, anchoring force here, Fr equal to Fx squared plus with Fz squared. To hold the elbow in place if elbow discharge water into the atmosphere. Elbow discharge water to the atmosphere. What does it mean? What does it mean? Elbow discharge water into the atmosphere. Someone? If the question mentioned about it, the elbow discharge water into the atmosphere, you should assume that someone?
P equal to 0.
P what?
P2.
Yes, correct. So P2 here is 0. Good. Okay, this is 0 lah. We don't have the P2. P2 is 0. What am I doing here? Okay, P2 is a 0. But you still have the P1 here. Is it given for the P1? Ada P1 ke? Is there P1?
Tak ada dia.
So how you want to
Ada.
find the P1? It's not given P1.
Pakai equation.
Sorry?
Equation yang Bernoulli equation tu.
Yes, Bernoulli equation. So the missing here is V1. P1. It's happened here, P1. Alright, you don't have the P1 and P2 is 0. You already have the P2, V2 and also the V1. So now we go to find for the P1 first. Kenapa kita nak cari P1? Because in the question earlier, it's already stated that P1 is include for the total force of the resultant force. Is it? Nampak tak tadi? This one? Which one? Wait, sorry. Where is it? This one. Okay, this one. Did you see? You need to find for the pressure, for the net force, total force. So you need to find the pressure. It's okay if you don't want to find the pressure first. Sebabnya the end, if you do for the equation for the x direction ataupun y direction, you still need that pressure at 1. So that sebelum kita go for the further for the resultant force ataupun FR, not resultant force, for the net force ni, we need to find kita cari P1. Siap-siap. So Bernoulli equation, we go for the Bernoulli equation. Okay, someone state for the Bernoulli equation.
P1 over gamma yang rho G tu plus Z1.
Yang apa tadi?
Tak, yang gamma betul
Okay, gamma. Okay, plus
tak? Z1
Z1
plus V1 square over 2G equal to P2 over gamma plus Z2 plus V2 square over 2G.
Okay, very good. Okay, now, so we focus on the P1 here. Now, before we go to the P1, kita tengok dulu the assumption that we can cancel out from the equation. What is it? Can someone tell me?
P2 over gamma.
Sorry? P2 over gamma. Since the P2 here is 0, what else? Tu je. Okay, never mind. We just go for the P1 gamma equal to what else? We just V2 squared minus V1 squared over 2G plus with the Z2 minus Z1. Betul tak ni? Did you get Sam with me? Class? Class?
Betul, madam.
Good. Okay. So now what you need to do adalah fill in the info here. Okay, never mind. You can also write here. We already have the 30 kilogram per second. This one adalah mass flow rate, 30 kilogram per second. We have also the A1, 0.015. We have also the A2, 0.0025. V1, 2 meter squared. V2, we have 12 meter, not meter squared, m over s, meter over second. And also you have the elevation here. Okay, elevation Z1 minus Z2 ataupun Z2 minus Z1 is 0.6 meter. And the weight for the total elbow is 50 kilogram. Okay, now by using all of this value data from the equation, we can substitute into this Bernoulli equation. Okay, someone please, bukan someone, semua. Alright, please calculate the final answer for the P1. So V2 here, please calculate 12 squared minus with the 2 squared times with the 2 times with the gravity, Z2 minus Z1. Is it 0.6 or negative 0.6?
Negatif.
Negative.
Negative.
Negative. Sure.
Sure.
Okay, kita ada 2 and this is 1.
Good.
So this is 0.6. What we need adalah Z2 minus Z1. So if we assume here 1 as a datum, 0. So upward is positive since this one adalah datum 0. So bawah is negative, upward is positive. So upward going to the second datum is a positive 0.6. So it means 0.6. Boleh ke?
Boleh, madam.
Boleh.
Macam mana madam?
Macam mana?
Tak faham.
Okay, again. Okay, let's say kamu nak cari adalah Z2 minus Z1. So here, this is the datum 2. This is the datum 1. Inilah datum 1, datum 2. Alright, so if you assume here Z2 minus Z1, we want to find this one. So Z2 minus Z1. So if we assume the datum at the datum at 1 is a 0, it means that if something value going upward is become positive and value going downward is become negative. Is it? Is it true? Is it right?
Yes.
Right, madam.
That's good. So it means here Z2 is going upward and it's become a positive 0.6. Minus with Z1, datum kita adalah 0 tadi kat 1, so it's become 0. So the final answer for the Z2 minus Z1 is 0.6. Boleh? Nasuha, is it okay?
Okay, faham madam.
Faham? Faham Same. If you assume here Z2 as a 0 as a datum, sama je. If you assume 2 as a datum 0 and 1 adalah, this is 2, this is 1. Okay, 1 is the going downward, it's become negative. Upward, it's become positive. So you still need Z2 minus Z1. So Z2 is a 0 datum. So 0. Z1, the value for the Z1, it become negative since it's going downward. So 0.6. Ni negative is a minus, but the value for Z1 itself is negative 0.6. It still become positive 0.6. Clear?
Clear madam.
Okay, clear. So tu be careful kamu tak boleh teka tadi you just guess negative 0.6. The end salah sebabnya if you are already wrong at the first of the step Bernoulli equation, kat sini P1 we will get the different value dan kamu masukkan dalam result net force nanti dia dah lari dah nanti jawapan dia. So be careful with this Bernoulli equation first, the basic one. Before we go further for the net force, kat sini kamu dah problem nanti. So make sure you are already strong at the Bernoulli equation. Saya dah terangkan hari tu, but never mind. Okay, this is so the end of the answer for the P1. Siapa dah calculate? Don't forget about this Sometimes student is forget about the power of 2 ni. Selalu. This one. Basic Bernoulli equation, you must strong at this basic. Alright, sebab this is just the early of the step. The next step, kamu nak masukkan dalam our net force. Kat situ bila the value for the pressure at 1 dah salah, nanti dia akan salah, dia lirik. But never mind, we just get strong, do some of more exercises. Okay, someone, P1. Nak saya kira. Someone? Saya dah suruh bawa calculator tadi. Someone?
686.7 kot.
6 ada kod 686 point kilo or pascal?
Saya dapat 75886.236.
Kilo or pascal? Okay, kita ada 2 jawapan. Someone else? Our row is, what is our row?
1000.
1000 water. Okay, 1000. Saya cakap sikit dia tergelabar dah. 75866 pascal. Siapa tadi dapat yang ni?
Salah madam, salah kira.
Okay, which part? Ini bukan nak malukan kita nak learn from mistake. Which part?
Saya lupa darab tu, yang omega tu.
Oh, this one. Alright, take note yang lain.
Tak
Alright, take
perasan.
note. This one, dia tertinggal. Alamak, apa saya buat ni? Alright, take note yang lain. Member tertinggal. Kita cakap ni supaya yang the rest boleh take note, jangan ulang lagi lah. So this one is wrong. So we go for this one. Alright, Pascal. For the pressure one, 75866 Pascal. Now we go for the next step. Since we have already the P1. Sekarang soalan apa? You need to find the anchoring force here. Anchoring force. Which one is anchoring force? So you need to find the resultant force ataupun anchoring force is the same one. So FR. You need to find for the FR. Next, adalah anchoring force. Which means here you need to find for Fr, we just have Fz squared plus with the Fz, right? Fx squared. Now we go to the first force, which means is a Fx. So we cover here for the x direction first. Sorry. X direction. Okay, x direction. So now, which one? Total force x direction equal to
0.
ah
Okay.
0. This one. X direction first. Okay, equal to m dot.
M dot
M
V.
dot V2 tolak V1.
Yes. Outlet minus with the inlet. Okay, m dot here you can assume kita tak perlu row Q lah since you already have the m dot here, 30 kilogram per second. Okay, now this one should be easy since you already have the V2, V1, and so m dot. But now we go to the first forces, total forces. This one. We go to the first total forces for the pressure, reaction, and the body for the total F. Okay, total F. So total F here, for the pressure here at the X direction, do you have inlet first? Ada ke? For the pressure, so we have here, right? Pressure. Guys, is it okay?
Okay, madam.
Faham dah ni? Oh, saya tunjuklah.
Kiranya pressure tu kita ambil yang P1 tu lah tadi kan?
Okay, this one. But the pressure memang P1, but that one as a pressure itself. But this one you must convert the pressure into the force. That's why we use this F equal to P and A. Faham tak maksud saya?
Faham?
Do you guys understand?
Kiranya total untuk Fx tu.
Yes, total for the Fx, it must be in the forces value. It means this is pressure, you need to convert to the force. Since you have the P1 here, so how you want to convert the force? You times with the area 1. So F equal to
PA.
faham? Kamu tak boleh guna just P1 here. No. This is just only the pressure. You need to convert to the force. You need to convert to the force. So that's why it become the P1 A1. And it don't need any of the angle since dia adalah memang X direction. And not only the X direction, you need to look at the direction here, positive. So the first direction adalah P1 A1 untuk pressure. Faham?
Faham, madam.
Okay, now we go to the total force. Number 2 is the reaction. The reaction ni lah yang Fx, Fy, or Fz. The one that you need to convert into, to fill in into this formula. So since this is x direction, we use for the Fx. This one you can assume any of the direction. Since this is, let's say lah, kamu kata nak assume this one as Fr. Alah, sama je. Okay, wait. Okay, this one. Fr. So this is Fx. So this is Fy. Assumption. Alright, this one. Fx, Fy, and we want that resultant force kat sini. Total anchoring force. So now Fx kita adalah opposite of this direction. It become negative Fx. Memang dia dalam fx, so you don't need 2 times with the area, you don't need 2 times with the velocity. So you just took the anchoring force here, reaction, fx itself here. What else? The force number 3 is the body. The body, it must be the weight of the anchoring force. Since the, okay, kalau kamu perasan, the anchoring force W is just only covered for the Y ataupun Z direction saja. So this one tak adalah. Untuk X direction, dia tak ada. Dia tak ada. It just used for the weight, is only have at the Z direction. Faham maksud saya? So it just only these two. Okay, now M dot. Yang ketiga tak ada, you just have 2 forces here. V2, mana V2? Which one is V2? This one. But the V2 is at the angle of the 40. Kita boleh ambil ke just V2? Can we just use that V2 into this question?
Tak boleh.
Boleh. Okay, you need to convert first. Never mind, jangan risau. So this is V2. Angle is 40. And this is X and this is Y. Sorry, saya terguna Y, dia biasa Y. This is Z. Boleh? Faham tak? So now kita nak the V2 in X direction. How is it? V2 in X direction, static. If you learn in static, you know how to get the V2 in angle 40 degree X direction. Boleh ke ni? Guys, can't you? Someone respond?
Of course, madam.
If you don't know, I can proceed.
Of course, madam.
Yeah, sorry. Nak saya
Course.
proceed ke?
Cos.
Cos. Okay, good. So, cos. Sini sikit lah, kan panjang. Okay, this one. Cos 40. Betul tak? So, we want the X direction. It become V2 in cos 40. To make it easy, we also cover for the Z juga. So, jadi apa Z? Sin
O. V2.
betul salah? Nasrullah, is it okay? Arif? Arif?
Tak tahu dah nak kira macam tu.
Tahu lah, madam.
Tak tahu?
Boleh kot kalau madam terangkan sikit.
Okay, so now you want to find the V2 in X direction. This one. V2 in Z direction. Since the V2 is at an angle, dia bukan straight for the X, it's not straight for the Z. Dia tak ada. So it have both directions, Z and also X. That's why we calculate this one V2. So selain daripada tu, you need to look for the angle juga, direction. So this one adalah ke arah sana. It means that X adalah negative V2. Sebab this one positive mesti ke arah to the right. So since this one the V2 is to the left side, it must be negative. What about this V2 for the Z? Positive or negative?
Negative.
Yes, it's downward. So it become negative. So now we already have both of the value for the V2. V2 here adalah V out. Which one? Pada X. X. So this one. So it become V2 cos 40. Don't forget about minus. Minus with the V1. Okay, V1 ni memang is at a X direction and also to the right. So it's already positive. Saya tak letaklah positif. I just mention here adalah minus V1. Sebab dia adalah, to make it clear, saya buat macam ni lah. Okay, this is the value for the V2. This is the value for the V1, positive. Since the to the right direction, it's become positive V1. Is it clear? So now you want to find for the fx. Leave the fx at the right and bring the others to the, saya letak je negatif, nanti kamu kira lah. Bring this one to the back. So next, you can get the nilai fx. If the value for the fx here adalah negative, the end if you find the value of fx in negative, it means that assumption here, the assumption that you made here is wrong. It's just the opposite way sepatutnya. Dia bukan ke arah to the left, it must be to the right. So don't worry, the answer that you get is, orang kata, is true, is okay. Tapi the end you need to state here that fx must be in opposite way ataupun opposite direction sebab dia ada nilai negatif. If kalau kamu kira sekarang, cuba try cari kira calculator nilai for the fx. Please guys, calculate for the calculate for the fx. Is it negative? Kira sama-sama. M dot is already there, 30 kilogram per second. So dia adalah 30 times with negative V2. V2 is already given to, what is V2? 12 cos 40 minus with V1 V1, what is it? V1, 2. Minus with P1, 75866 times with A1. You also have the value for the A1. So what the final answer? Is it negative or positive?
Saya dapat positif
Okay, positif berapa?
778.64.
Sorry?
778.64.
778.64.
64.
Someone? Siapa nak confirmkan? Yang lain kira tak korang? Guys, are you there? Sikit lagi ni, sikit lagi. Are you there? $778.64. Siapa boleh? Someone? I get 1473. Siapa dapat?
Saya dapat macam tu tapi negatif.
Okay, but saya dapat 1473. Betul ke?
Betul.
Nasuha, kamu nanti kamu check semula. 1473.77 lah. This one adalah negatif yang saya dapat. But yang sebelah sini pun dia negatif. So the real fx is become, we just cancel out. So 1473.77. Dapat tak? Betul tak?
Betul madam.
Betul. So the end, the direction for the fx is positive. So it means here, the assumption that we made adalah betul. Fx to the left direction. Okay. Ini adalah baru satu fx. So now we want go to the next force iaitu z direction. Saya nak cakap y je. So we go for the z direction. Okay, z direction. Okay, total fx, so total force and m dot v out minus v in. Total force, we go for the total force here, for the pressure. So since the pressure at 2 is 0, so we don't have for the P2. Anchor for the reaction, this one, Fy. So we going into the upward, so kenapa saya tulis Fy? Fz should be Fz. So it going upward, so Fz lah, and positive. Next, we have the third direction ataupun the body is given here. Which one? The mass of the elbow and the water 50 kilogram is going downward since it the mass weight. So it's a W. Kita ada satu adalah W. So negative W equal to M dot V2. Which one V2? V2 at Z direction. Kita already calculate. So negative V2 sines 40. V1 at Z direction, ada ke?
Tak ada.
Tak ada. So it's a 0. It should be easy for the Z direction, but we have W there. How you want to solve for W? You must convert into force. This one is weight. So macam mana? This is weight. You must convert into force. Someone?
Convert madam.
Convert the weight into the force. Sebab ini adalah W. Sama warna dah. This is W. Just the normal weight. Tapi we want that total force must be in a force. So that you must convert the weight into the force. So how?
Mass darab 9.81.
W equal to mg.
Yes.
So F, kita just leave the Fz here, m dot negative V2 sines 40 plus with W and m dot negative V2 sines 40 plus m g. Okay. Jawapan akhir. Someone. Bukan someone, semua. What's the value for the V2? Oh, sorry. Okay, dah betul lah. Saya letak negatif. Betul lah tu negatif. V2, what's the value for the V2? Negatif. So make sure before you do the proceed with the solution, you list out ataupun list out all the important value in the question dekat luar. Sebabnya nanti bila the end masuk final, barulah kamu nak check balik which one is V2, which one is V1. You need to list out first. Given. Okay? You need list out the given first here. So that way when you want to do the equation, do the solution, kamu boleh straight nampak the V2 nilai adalah 12. So tak perlulah baca soalan. Sometimes student dekat soalan lain, tapi bila the list the given lain jawapan dia. Tapi at least you list out so that I can see dia ada kecuaian kat situ. So the end tak adalah saya tulis kosong. It means that the marks you don't get for the zero. There's something wrong with the, kita just potong sikit markah je lah. That's why you need to show all the jalan kerja secara details. Alright. Next. Bukan next. Siapa dah dapat? What's the mass? 50. What's the value for the FZ? This is one dia simple. Tak macam atas dia complicated sikit. Berapa nilai FZ? Guys?
259.1.
259.1 Newton. Okay, yang lain?
Sama madam.
Sama? Yang lain?
Madam, M dia berapa tadi?
M, look at the question, the mass of the elbow and water 50. $259.1. Boleh? So I also get the 259.1 Newton. So that's good. So since we have already the Fz and also the Fy, Fx and also the Fy. Okay, next we just proceed with the question. You need to find the anchoring force Fr. Fr, the end is become Fx squared plus with the Fz squared. So Fx 1473.77 squared plus with 259.1 squared. Okay. Can someone? Someone? Saya dah bagi dah. Is it same? With you guys?
Yes.
Yeah, good. Siapa tu yang yes tadi? Muhammad apa?
Sama madam, sama.
Sama. Alright, you get the same answer with me, 1496.37 Newton. So now this is your the anchoring force. Sometimes for the safe, okay, just proceed with the theta. So tan, which one? Tan what? Fz divide by
Fx.
right? Tan inverse. Sorry. Fz divided by Fx. So the end you will get the answer for the tan inverse. Fz, what's the Fz? 259.1. For the Fx, 1473.77. Okay, what did you get?
9.97.
9.97. Okay, so you have the anchoring force here. Okay. This is quite simple. Sebenarnya dia more complicated. For the October 2012 tu, actually it's quite complicated. So if you don't kata fluent with the basic one like this one, kamu tak boleh jawab October 2012. That's why I go for this question first. I go for the question first. Is there any question for this equation? Dia quite panjang since dia adalah 12 mark here. So that's why lah nampak macam wow. Okay, tapi dia memang 12 mark. So you have the Bernoulli equation, you have the inquiry force, x directions, z direction, and also the end you need to find the inquiry force. Do you have any question about this question? This is October 2016. You can also find the other question, previous question for the September 2019 is also quite a basic question jugalah. So before you proceed with the October 2012. So now, someone, nak habis bateri dah. Someone at the end? So now, to the end of the class, do you have any questions? Beside for this question, ada nak tanya ke? This is a common.
Saya ada soalan ada.
Yeah, sorry.
Saya ada soalan.
Okay, which one, Arif?
Bukan soalan yang kita jawab hari ni, tapi soalan yang assignment hari tu ada.
Oh, soalan assignment. Kamu dah hantar ke?
Yang explain tu madam. Tahu nak explain kan?
Oh, kenapa tak ingatkan saya? Senyap je dalam group. Tak ingatkan saya pun. Saya akan bagi after class ni saya akan respon lah. So for this question first. Saya akan bagi lepas kelas nanti. For the question number 1 for assignment 1. Tapi saya nampak semua dah hantar. But never mind. Okay, siapa ada question? Anything you want to ask about the linear momentum? Tomorrow we proceed for the chapter 4, but today we just end up for the chapter 3 and some equation to ulang kaji sajalah, exercises. Okay. Anything you want to ask about the chapter 3?
Madam, nak tanya
Yes.
boleh tak?
Okay.
Tapi bukan soalan ni. Soalan Oktober 2012.
Alright, okay. Why? October 2012 eh. Tak lama. Alright, okay.
Nak jawab. Saya tak dapat jawab tau sebab apa kan dia kena guna Bernoulli equation kan. Tapi dia tak bagi V1 atau V2.
V?
Hmm.
You means dia tak bagi V ke? Okay,
Jadi
that's
dia kena
why.
guna equation
first-
Bernoulli tu kan.
Sorry, Nazha, the first thing here you need to look at the question. Determine the volume flow rate. Determine the volume flow rate of the oil through the band. It means that the volume flow rate is m dot q w. Which one? Volume flow rate. Number 1.
Q kan.
Q. Is it? Okay, W flow rate is Q. Q equal to AV. Nampak tak kat sini? Soalan ni is quite trick. Sebabnya you need to find the V first ataupun Q. Baru you can proceed with the anchoring force. Baru kamu boleh proceed dekat sini. So soalan ni dia memang the equation yang kamu buat adalah total, let's say I show you for the x direction here. Boleh saya tunjuk sekejap, ada 5 minit?
Boleh madam.
Okay. So here apa yang ada adalah, siapa yang dah buat lah. Bagus siapa yang dah buat. So this is inlet. Okay. So this is inlet. So this is V1 and also this is P1. You also have the P2 there. And it doesn't mention that, okay, this is P2 and this is V2. Be going out. So that's one is V2. The surface of the cross sectional, that's why it's going upward there. Okay, kat sini kamu ada. So for the x direction, do you have the weight? No, you don't have the weight. So for the x direction, total force equal to m dot V2 V outlet minus dengan V inlet kat sini. So untuk V total force ni you already given the Fx sebenarnya kat sini. But for this question sebenarnya Fx at the question and also Fx in the figure here is quite different. 6.5 ni adalah 7.5. But never mind, you just choose which one sebab dia takkan ada quite a bit small differentiate between the numbers saja nanti. Okay, tak ada apa. You can use the 6-5 ataupun 7-5, either one. Okay, so total force here, you have 1 and coring force. 2 adalah pressure. Which one? Pressure. So pressure adalah P1A1. And number 3, you don't have the weight. So kita ada just 2 total force here. So dia ada adalah assumption. This is Y, this is X, this is positive. So since go to the right, it's positive 6268.75 Fx. Then you also have the second forces here. So which one? This one. And the P going to the left side, so it's minus P1A1. What the crucial here at the side, at the right side here, M dot equal to rho Q ataupun rho AV. Betul tak? M dot equal to rho Q or rho AV?
Rookie.
Rocky madam.
Sama je. Maksud saya this is also correct for the rho AV. Q equal to AV. Itu maksud saya. Alright. Okay, now V2, which one is V2? This is V2. So V2 you have 45. This is V2. So you have for the X directions, kita nak X direction, yang the rest nanti you calculate later. So sine or cos? Positive or negative? Positive or negative?
Negative.
Yes, negative. See? At the left, so negative V2 sines 45. Minus with V1. V1, negative or positive?
Positive.
Guys, to the right is positive since the V1 inlet kita adalah to the left since ia adalah negative V1. Did you get that?
Yes, madam.
Nampak Did you see the difference? So this one adalah negative V1 since the V1 is go to the opposite of the X positive. So that's why it's negative V1. Okay, now you have V1, you have V2. It's two unknown there since you don't have any of the V. What you need to do adalah you need help from the continuity equation. Which one? Continuity equation. What is continuity equation? Guys, continuity equation. What is continuity equation? You need help from the continuity equation. You need to convert. You need to maintain only one V. But since there are two unknown V, we just need one V. So you need continuity equation. How? Q1 equal to Q2. What else?
A1 V1.
V1 equal to
A2, V2.
A2, V2. So A, it doesn't matter for you since already given for the diameter here. So now you can choose either one. You want to maintain the V or V1 or you want to maintain the V2. It's up to you. So in case you want to convert the V1 into V2, boleh juga. So V1 equal to A2 over A1 V2. So kamu akan substitute. This one adalah equation 1, this one adalah equation 2. Substitute 2 into 1. Okay, so you need to substitute this V1 into this one. So it will be in the value of V2, the end dia. So nanti yang the end kat hujung tu dia akan jadi seperti inilah. Negative V2 sines 45. Negative. Saya dari negatif tu saya jadi positif lah. So easy for you. See, just only ada V2. So the end you can orang kata focus on V2 saja. So how about the row Q? This row Q is equal to A1 V1 or A2 V2. Since we just maintain for the V2, you can also convert for the Q A2 V2. So kamu akan ada satu bacaan for the V2 je at the rest. So the end, this one tak ada masalah, kamu dapat. So the end kamu akan dapat nilai V2.
So kiranya Q tu madam boleh pilih lah. Nak ambil
Yes, you can choose either one. You just need one V saja. Since untuk case macam ini, you need help from the continuity equation. Okay? In case kalau kamu rasa, no, I don't want the V1 convert into V2. Saya nak convert this V2 into V1. It's also boleh. So dia akan jadi bacaan V2 dalam V1. So A1 over A2 yang ni lah. So dia nak V2 lah. Let's say dia nak convert V2 into V1. So it become A1 over A2 V1. Dia akan dapat dalam bacaan V1 pula nanti. So di V1, di V1. So Q, you choose lah A1 V1. It's quite complicated kat sini for this equation saja. So if you solve for the parts, then you get the V1 or the answer for the V2, it should be easy for you the rest. Since you can get the row Q and also you can also find the anchoring force FAY pula. Go to Y direction. Dia dua step je, just need 2 step. You don't need that Bernoulli equation, tapi it's quite complicated. Dia dah jadi maths problem on that part. Alright, but you must understand the basic. Okay, don't be worried. You nampak, oh, it's too unknown here. You have V1, you also have the V2. How I want to solve the problem? Don't worry, you still have the continuity equation. Okay, inlet in equal to inlet out. In case you must consider it as an incompressible flow. Means the water must be inlet same with the outlet. So kalau dia masuk water, it must be outlet pun water. Tak boleh lah masuk water, at the end outlet dia keluar adalah oil. So kamu tak boleh gunalah continuity equation. The continuity equation, the part of the syarat dia, it must be incompressible flow. Density must be maintained in sampai out. Okay, so you can use this continuity equation, incompressible flow. Okay, is it clear? Nasuha, is it okay? You can proceed. If you don't get the answer, you can text me aside. So you can show sampai mana you start, then I can help you. For the rest of the student, you can also text me if you have any question juga. I have only 1% also, sorry. Okay, ada soalan lagi? So it's 3:14 p.m. It just end of our class. If you have any other question for the linear momentum, you should know how to calculate for the anchoring force, resultant force x direction, y direction, and also z direction. If you have extra time after this, I can show you this one. Okay, this is you have x direction, y direction, and also z direction. It's 12 marks, but the calculation is quite simple compared to the 2 questions earlier yang kita discuss tadi. I can show you how to solve this problem, but not today lah, since we have end our class for now. Before that, do you have any question?
No, madam.
No, thank you, Nasuha. And the rest, is it okay?
Okay, madam.
Okay, madam.
Good. So I give you this copy. So dia ada juga dengan answer. You try it first. If you can't get the answer yang dekat bawah ni, answer. Alamak, sorry, dia dah habis bateri. Okay. Nanti saya akan bagi. If you don't get the answer for each of the question, you can ask me how to solve. But please make sure you done it first, and saya akan tengok which part yang kamu stuck. Okay, I think that's all for today. Recorded video I will give to you and pass to your friend yang tak dapat yang berada dalam masalah banjir tu, yang kat mana-mana kampung mereka berada and have a problem with the internet connection, you just pass this video to your friend, alright? And also you can bagi tahu mereka lah, if kalau diorang ada masalah juga boleh text me lah, bukan sekarang, maybe diorang ada masalah later soon, bila diorang masa lapang and buat soalan baru tanya saya lah bila ada masalah. Alright, but tomorrow class is still on 8:30 AM as usual. Alright, I think that's all. Okay, thank you guys. If you don't have any question, you can leave the platform. I will give you the attendance links sekejap lagi. You have 15 minutes to fill in the attendance link. Okay, that's all for today. Thank you. Assalamualaikum.
Waalaikumsalam. Thank you, madam.
Thank you, madam.
Thank you, madam.
Okay,
Salah, thank you, madam.
sama.
Thank you, madam.
Alright.